Welcome back to episode 13 of The Gray Files, where we peel back the layers of technology, economics, data science, and even the human condition itself, all in an effort to try and understand this vast and often perplexing world we live in. I'm your host, Erica Barker, and tonight we're wrapping up our 3-part deep dive into data science. Now, if you've been following along, we've covered how data scientists basically became the puppet masters of the internet. And we've looked at the math wizardry they use to turn your Netflix viewing habits into, well, more Netflix recommendations. But tonight, we're talking about what happens when this whole field moves so fast that even the experts are like, what just happened? So let's imagine for a moment that you're a carpenter, and every 6 months, someone invents a completely new type of hammer that makes your old hammer look like a caveman's club. That's basically what it's like being a data scientist right now. Except instead of hammers, it's algorithms that you can write poetry, diagnose cancer, or decide whether you get that loan. We're in what insiders call the data Wild West. And trust me, that's not just a catchy name. It's like the California gold rush, but instead of pickaxes and a pan, people are using Python code and neural networks to strike it rich. Part 1. Wait, what do these people actually do? Now here's the thing that's driving everyone crazy right now. Nobody can agree on what a data scientist actually is anymore. It's like if you asked 10 people what a consultant does, except somehow even more confusing. Remember back in 2012 when Harvard Business Review called data scientist the sexiest job of the 21st century? Yeah, well, that was before anyone figured out what the job actually was. It was like declaring unicorn trainer the sexiest job before anyone had seen a unicorn. So let me break this down in plain English. You know how your weather app tells you there's a 30% chance of rain? Someone had to teach a computer to look at satellite images, temperature readings, wind patterns, and about 1 million other things. Then figure out the math to turn all that into grab an umbrella, maybe. That's data science. But here's where it gets messy. These days, you've got machine learning engineers. Now, these folks are the people who take the weather prediction algorithm and make sure it doesn't crash when millions of people check their phones at 7 a.m. Think of them as the difference between a brilliant chef who can make an amazing meal for 4 people and the person who figures out how to serve the same meal to 40,000 people without burning down the kitchen. Then we have data engineers. Remember those old Rube Goldberg machines from cartoons? The ones where a ball rolls down a ramp, hits a lever, which tips a bucket, which pulls a string. Data engineers build those, except instead of making toast, they're moving customer data from your shopping app to the recommendation engine to the marketing department without everything exploding. Now, AI researchers, these are the people trying to build actual artificial brains. Not just show me cat videos, but understand what makes something funny or figure out how to drive a car without it killing anyone. They're basically trying to reverse engineer how thinking works. Now, here's the funny part. And by funny, I mean completely frustrating if you're trying to hire someone. CEOs keep confusing data scientists with what are called prompt engineers. A prompt engineer is someone who's really good at asking ChatGPT the right questions, like Instead of asking, write me a marketing email, they know how to ask, write me a marketing email for busy parents about time-saving kitchen gadgets. Keep it under 150 words. Use a friendly but not overly casual tone, and include a clear call to action button. It's a skill, sure, but it's like the difference between being a great Google searcher and being the person who actually built Google. Then there's the whole data analyst confusion. This one actually makes sense because the names are pretty similar. But think of it this way. A data analyst looks at last quarter's sales numbers and says, we sold more ice cream in July than in January. A data scientist looks at those same numbers plus weather data, social media trends, and economic indicators and says, based on the weather forecast and current TikTok trends, we should order 23% more strawberry ice cream for next month. So one tells you what happened, the other tries to tell you what's going to happen. Both are super important, but they're completely different jobs. Part 2. Lost in translation. You know what's harder than building an AI that can beat grandmasters at chess? Explaining to your boss why that AI can't also automatically fix the office printer. This is where data scientists spend half their time. It's not coding or building models, but trying to explain to normal humans why computers aren't magic. Picture this conversation that happens in every company every day. The boss goes, so our churn prediction model says customers are 73% likely to cancel their subscription. That means they will cancel, right? The data scientist responds, well, no, it means that in similar situations, about 73 out of 100 customers typically cancel, but there's uncertainty around that number, and it assumes our historical data applies to current conditions, and so yes or no. Cue the internal scream and the window that data scientist now wants to jump out of. It's like being a weather forecaster. When you say there's a 30% chance of rain, some people hear, it definitely won't rain. Others hear, it's definitely going to rain. And a few people hear, there's a 30% chance of rain. Only the last group is right, but good luck getting everyone on the same page. The really successful data scientist, they become part translator, part therapist, part magician. They learn to say things like, think of it like a really smart basketball scout. They can tell you this player scores 23 points per game on average, but they can't guarantee he'll score exactly 23 points in tonight's game. Marketing wants proof their campaigns work. Sales wants to know which customers will buy. Operations wants everything to run faster and cheaper. Everyone wants certainty in a world built on probability. It's like asking your GPS for the one perfect route when traffic changes every 5 minutes. Part 3. When algorithms go to war. Now we're getting into the really wild stuff. Remember when the biggest worry about computers was Y2K? Quaint times. These days, countries are basically having Pokemon battles, but instead of Pikachu, they're using AI algorithms. Russia uses bots to spread fake news. China builds facial recognition systems that can spot you in a crowd of 1 million people. The US has AI that can identify enemy targets faster than any human pilot. But here's the scary part. It's not just governments anymore. Remember the 2016 election? A big chunk of what people saw on Facebook was determined by algorithms trying to maximize engagement. Turns out, nothing gets people engaged like making them really, really angry at each other. Whoops. It's like if you designed a system to make parties more fun and you discovered that starting arguments gets people talking more. So your algorithm starts introducing controversial topics every 5 minutes. Technically, working as designed, but probably not what anyone wanted. Now we've got AI systems that can create fake videos of politicians saying things they never said. They can write news articles that sound totally real but are completely made up. They can even generate fake scientific papers that look legitimate until experts dig into the details. The really nutty part? These systems are getting good enough that they can test different lies on small groups of people, figure out which lies work best, and then spread those personalized lies to millions of people faster than fact checkers can say, wait, that's not true. It's like if telemarketers could instantly test 1,000 different sales pitches, figure out which one works on you specifically, and then call you with that exact pitch while you're in your most vulnerable mood. Except instead of trying to sell you a timeshare, they're trying to convince you that your neighbors are your enemies. Part 4. The Surveillance Shopping Mall. You know how when you browse for shoes online, suddenly every website shows you shoe ads? That's just the tip of the iceberg. Companies aren't just tracking what you buy anymore. They're building psychological profiles to predict what you'll want before you know you want it. Amazon doesn't just recommend products based on your purchase history. They're trying to figure out what you'll need next Tuesday. Your insurance company might be looking at your social media to see if you post pictures from risky activities. Some employers use AI to analyze your facial expressions during video interviews. Landlords are running your digital footprint through algorithms that decide if you're a good tenant based on data you didn't even know existed. It's like if your local grocery store followed you around town, noted everyone you talked to, tracked how fast you walked, monitored what you looked at in other stores, and then used all that information to decide what to charge you for milk. Except it's not just one store, it's everyone. Credit scores used to be simple. Do you pay your bills on time? Now they're evolving into these comprehensive trustworthiness scores that include everything from your shopping habits to your social connections. Some systems even analyze how you type on your keyboard or move your mouse to build a profile of your personality. The weirdest part? Most of this is invisible. You might get rejected for a loan because an algorithm decided your Netflix viewing habits indicate you're financially risky. You'll never know that's why, because the system just says, application denied. It's like being judged by a panel of experts you can't see, using criteria they won't explain based on information you didn't know they had. Part 5. Robots taking over, but not how you think. Forget Terminator. The real robot takeover is way more boring and way more important. Every time someone builds an AI system that can do a human job, we collectively decide to let machines make those decisions instead of people. Usually because it's faster, cheaper, or more consistent. But we're basically trading human judgment for algorithmic efficiency, one decision at a time. Think about driving. Right now, you make thousands of tiny decisions every trip. When to change lanes, how close to follow the car ahead, whether that pedestrian is about to step into the street. Self-driving cars will make all those decisions using algorithms trained on millions of hours of driving data. The same thing's happening everywhere. Algorithms already make most stock market trades. Humans are way too slow. AI screens job applications before any human sees them. Computer systems approve or deny loans that used to require a human underwriter to review. Each individual case makes perfect sense. Algorithms don't get tired, don't have bad days, don't play favorites. But add it all up, and we're slowly delegating more and more human judgment to mathematical models. The problem is, when these systems fail, they fail big and weird. Remember the 2010 flash crash? Algorithmic trading systems basically had a conversation with each other that went something like this. Algorithm A: lots of people are selling, prices must be dropping, I should sell too. Algorithm B: Algorithm A is selling, prices must really be dropping, I should definitely sell. Algorithm C: everyone's selling, this must be a crash, sell everything. In about 36 minutes, they wiped out nearly $1 trillion in market value. Humans eventually figured out it was a computer glitch and fixed it, but for those 36 minutes, the machines were making all the decisions and they decided to panic. Part 6. The big question mark. Here's where things get really science fiction-y, except serious researchers think it might happen in our lifetimes. Right now, all AI systems are basically very sophisticated calculators. They're incredible at specific tasks, beating humans at chess, recognizing faces, translating languages, but they can't do anything outside their narrow specialty. It's like having a calculator that's amazing at multiplication but has no idea what division is. But researchers are working toward what they call artificial general intelligence, or AGI. AI that can learn any task humans can learn just by being shown examples. Think of it like the difference between a player piano that can only play songs from its specific rolls, and a human musician who can hear any song once and then play it. If that happens, and it's a big if, everything changes. An AGI could potentially learn to be a doctor, engineer, artist, and scientist all at once. It could read every scientific paper ever written and make connections no human ever thought of. It could solve climate change, cure cancer, and design technologies we can't imagine. Or it could decide that humans are inefficient and need to be optimized out of existence. Nobody really knows. The wild part is that this isn't some distant future fantasy. The same techniques that power ChatGPT and image generators are the building blocks for potentially much more powerful systems. Every breakthrough in making AI more capable gets us closer to something. Nobody's quite sure what. It's like we're all passengers on a train that's accelerating toward a tunnel, and everyone's arguing about whether there's light at the end or a brick wall. Part 7. Plot twist. We need them more than ever. Here's the thing that surprises everyone. As AI gets more powerful, we actually need more human data scientists, not fewer. Every new AI tool creates new problems that need human experts to solve. When everyone has access to powerful algorithms, knowing how to use them properly becomes super valuable. It's like when calculators became common. Suddenly, everyone could do arithmetic, but you still needed mathematicians to know which calculations to do. As AI systems make more decisions, we need more people who can audit those systems, figure out when they're making mistakes, and design safeguards to prevent algorithmic disasters. When a recommendation system starts showing people increasingly extreme content, you need a human to understand what is happening and how to fix it. Plus, new applications keep popping up everywhere. Climate scientists are using AI to model weather patterns. Doctors are using machine learning to analyze medical scans. City planners are using algorithms to optimize traffic flow. Each field needs people who understand both the technology and the domain. You can't just drop a generic AI system into cancer research and expect it to work. The really interesting part is that as AI handles more routine tasks, data scientists are working on increasingly complex and creative problems. Instead of just optimizing existing processes, they're discovering entirely new possibilities and asking questions nobody thought to ask before. Part 8. The Secret Puppet Masters. Here's the thing most people don't realize. The data scientists we've been talking about, people like Sarah Chen, working late nights in Silicon Valley, they're making decisions that affect millions of people's daily lives. Every recommendation algorithm decides what information you see. Every predictive model influences who gets opportunities and who gets overlooked. Every optimization system changes how resources get distributed and how power flows through society. And most of them are just trying to solve interesting technical problems. They're not sitting in dark rooms plotting world domination. They're usually just trying to make their models 2% more accurate or reduce processing time by a few milliseconds. But those tiny improvements, multiplied across millions of users, add up to massive social changes. It's like how individual raindrops don't seem important, but enough of them can change the course of rivers. The crazy part is how invisible this all is. When the Industrial Revolution happened, everyone could see the factories and smokestacks and assembly lines. Now the algorithmic revolution is happening inside servers and smartphones, completely hidden from the people it affects most. Your Spotify playlist, your dating app matches, your insurance rates, your job opportunities, they're all shaped by algorithms built by people you'll never meet, using methods you'll never fully understand, optimizing for goals that might not align with what you actually want. Part 9. The story that's still being written. The future isn't predetermined. It's being written right now by thousands of data scientists making technical decisions that have human consequences. Whether AI serves humanity or the other way around depends on what choices they make. Not just technical choices, but choices about what problems to solve, whose voices to listen to, and what values to build into their systems. The good news is that more people are starting to pay attention. Data scientists are thinking more about the broader implications of their work. Companies are hiring people specifically to think about AI ethics and safety. Governments are starting to regulate algorithmic decision-making. But ultimately, this is a human story about human choices. The algorithms shaping our world aren't natural forces like gravity or weather. They are human creations that reflect the priorities, biases, and the blind spots of their creators. Understanding how this all works isn't just interesting, it's essential for anyone who wants to navigate a world increasingly run by algorithms. Because whether we like it or not, we're all living in the future that data scientists are building, one data set at a time. The question isn't whether AI will continue getting more powerful. That seems inevitable. The question is whether we'll maintain meaningful human agency in an algorithmic world, and whether the systems we're building will reflect our best intentions or our worst impulses. The data scientists we followed in this series hold some important keys to that future. Understanding their work, their challenges, and their influence isn't just curiosity. In a world run by algorithms, it might be survival. And with that being said, this concludes our 3-part series on data science. I'm Erica Barker, and thank you so much for joining me on this journey through the hidden world of data and decision making. Until next time, keep asking questions, keep learning, and remember, in an age of algorithms, the most important skill might be knowing which questions only humans can answer.